Exercise 2. The document 1 shows the variation of speed as a function of time for a car moving on a straight line. Determine the speeds of the car VA, VB, and VC at a point A, B, C. VA, we draw orthogonal projection from A on the y-axis. It's 30 meters per second because the scale here is 5 meters per second. So we have here 20, 25, 30. VB the same, 30 meters per second, and VC is on the y-axis. If you project it on the, it's on the x-axis. If you project it on the y-axis, you also obtain 0. So VC is 0 meter per second. Now specify the type of motion along OA, AB, and BC. The type of motion along OA is UARM, since the graph of V versus T is an increasing straight line. The speed here increases uniformly. AB, URM, uniformly rectilinear motion, since the graph of V versus T is a horizontal line showing constant speed, constant instantaneous speed. BC is UDRM, uniformly decelerated rectilinear motion, since the graph of V versus T is a decreasing straight line. Now calculate the acceleration of the car along OA, AB, and BC. Acceleration along OA between positions O and A, this means that we are looking for the average acceleration. The average acceleration OA is equal to delta V over delta T, which is V final minus V initial over T final minus T initial. For this range, V final is A, VA minus V naught, V0 is the initial, TA minus T0. We do the substitutions, we get 5 meters per second squared. The average acceleration for the range AB is VB minus VA over TB minus TA. So it's 30 minus 30 over 14 minus 6. It is 0 meters per second squared. So, and ABC is equal to final minus initial VC minus VB over TC minus TB. We get minus 3 meters per second squared. This agrees with the types of motion, because uniformly accelerated means there is acceleration different from 0 and positive. URM means there is no change in the speed, acceleration is 0. And BC is uniformly decelerated rectilinear motion, so the acceleration is negative, the speed decreases. Now exercise 3, the position time equation of a vehicle considered as a particle is given by the following relation. X of t is minus 2 t squared plus 10t. Specify the nature of motion. Uniformly decelerated rectilinear motion, since it is in the form of x equal half a t squared plus v naught t plus x naught. This is not enough. You have also to say and a is negative. How did we know that a is negative? Because the coefficient of t squared in the general equation is half a, and half is positive. So the coefficient, the sign of the coefficient is actually affected by the sign of the acceleration. If the sign of the acceleration was positive, then the coefficient of t squared is positive. If the sign of a is negative, then the coefficient of t squared is negative. So here we have minus 2 as coefficient of t squared. That's why we can conclude that a is negative. Determine the initial position and the initial speed of the vehicle by comparing x equal minus 2t squared plus 10t to the general equation. We have that the coefficient of t is v naught in the general equation, and here it is 10 meter per second in the SI unit. And x naught is equal not to 2, it's actually equal to 0. So we have to correct this one. It is equal to 0. Why it's equal to 0, not to 2, as you might think? Because we have 10t, the point in the general equation. Is x naught multiplied by t, is it dependent on time? No, it's the initial position regardless of the time. So we have no constant added here. This means that it is plus 0. So in this case, the object started moving from the origin of the reference. Now determine the acceleration of the vehicle by doing half a is equal to the coefficient of t squared, which is minus 2. Then you do cross multiplication and you get a equal minus 4 meters per second squared. Write the expression of the speed of the vehicle as a function of time. So the general equation for UDRM is v equal at plus v naught. A is minus 4 and v naught is 10. So minus 4t plus 10, where t in seconds and v in meters per second. You have to mention this. Calculate the position and the speed of the vehicle at t equals 2 seconds. So we say x2, x index 2 to show that it is at it belongs to t equal to half a t2. This index also shows this squared v naught t2 plus x0. Doing the substitutions, we get that x2 is equal to 14 meter. Now concerning the speed, we have to refer to the and doing the substitution in the equation here, minus 4 into 2 plus 10 minus 80 plus 10 is equal to 2 meter per second, where t is in second and v in meter per second.